Hello everybody, welcome to this episode of Programming and Algorithms. In this episode we're going to look at two different features of Python, modularization and then software testing. So we'll start with how we do modularization in Python. So if we remember our prime number checking program, we remember it. This is the code as we saw in a previous episode, and I made the point before that you could divide that into two separate blocks. In essence, there's a block that checks if the number is prime, and then there's a separate block which is printing out a message saying if the number is prime, print out a message saying it is prime, else print out it's not. So they do two different things, and in programming we have a principle called cohesion. One program is best if it does one thing well, not two things half well. So if you can have one program doing one thing well, that's considered a very coherent program. Whereas the program is doing multiple functions, then it's considered less coherent. So we could divide that, split it into two different modules or methods or functions, whatever we want to call them, subroutines, procedures. So how we do that is, unlike in our pseudocode where we said module, is it a prime? In Python what we do is we use the special word def, and we define a function called isItPrime, open bracket, close bracket, and then everything after isItPrime, open bracket, close bracket, colon, is indented, tabbed out, because you can see everything else is spaced out until we get to the end. Now, as we've mentioned before, I'm going to ask that you do hash in isItPrime at full stop at the end of this, but you don't actually have to do that. So we've just taken the code for checking if it's prime, and we've added a special word in at the end that's return. So these are the two new bits really. Define the name of this program, isItPrime, and then the function of this program is that it returns a value back, and returns a value back that's a Boolean value, true or false. So now let's look at the main part of the program and the other half of it. The other half of the program is this now. This is all the program does anymore. It just says if isItPrime is true, then print it's true, else print it's false. So because we've wrapped up all the code for just checking if something is prime into this handle, this name called isItPrime, all we do is call that. If it returns true, the number is prime. If it returns false, the number ain't prime. So we've split the code in half nicely now. A somewhat related thing, because it's fiddling around with the same kind of code, is software testing. We're going to go into a great amount of detail about testing in the second semester, but just for the sake of this stuff, I want to point out that good programming practice indicates that we should add in checks, error checking and things like that all the time. So testing isn't about to see does the code compile or does it work, it's how well does it work, what is the quality of the code, does it work well. If we take the prime checker program again, then something that I would typically do when I write code is put in some error checking code in it. So something like this, which says when the program runs, I'd prompt the user with a question saying, do you want to turn error checking on or off? And if they say yes, I'd set a Boolean variable error checking on to be true, otherwise I wouldn't. The rest of the code would be as is until we get to when the program decides that a particular number is not prime. Then it prints out a message here saying division with remainder 0 found, and it prints out what denominator is the divisor that divides evenly into the prime number. And then there's a check later on that says print out A and B as well. So if at the start of the program I say no, I don't want error checking on, then my error check will be false. Neither of these statements will be executed. Or if I say yes, I want error checking on, it will actually tell me what values are causing the result to come out as not prime. And then it's the same code in the rest of it. Let's take another program. Let's look at the Fibonacci number sequence one. So this is the Fibonacci number sequence code as it was. So I might add in the same thing again and say, we could add in some error checking and just say, same as before, let's prompt the user at the start saying, do you want error checking on or off? And then we might add in code here saying, if error checking is on, then print out the first number and the second number and the total each time around the loop. Sometimes if let's say with Fibonacci number sequence, if it was giving me the wrong number, the wrong answer, I'd just put in a print statement to see what first number, second number, and total were each time around the loop. Rather than just put that print statement in and then take it out afterwards, what I do is put an if statement around it saying, if error checking is true, always print this out. So then I get to see what's going on in terms of the inner workings of the code. So it's over to you now. Look at the code you've got already, add in some error checking yourself and see how that works. We'll see you in the next episode.